Well, thanks, Jenny. That was awesome, and thanks everyone again for hosting us here. And yeah, just a little side note, as Jenny mentioned, I'm with the USDA Forest Service, also out in Salt Lake City. And in case you're wondering why the Forest Service is involved here with NASA, we have a long relationship and working with NASA that goes back multiple decades in using NASA assets for resource management. Not just fire management, but forest management and so forth. And we've worked closely with NASA, wow, for almost 25 years to utilize their satellite assets and data processing capabilities and data delivery processes to monitor and map active fire activity throughout the United States and Canada. And as Jenny said, we moved things further under the NASA umbrella here just a few years ago, and worked totally inside of the firm's umbrella here. And so, what I'm going to do here today is going to take another trip through the fire map here and show some additional functionality. But then after that, as Jenny mentioned before, I'll spend a little time. I'll dive into these other aspects of the firm's interface. Where you can access web services, download archive data. You can set up fire alerts if you like to be alerted when activities are occurring, and also downloadable data sets that are provided if you want to use products in your own system. So let's jump into the map here again. And as Jenny said, when you first start up, you're in the basic mode. And most users will like to use the advanced mode, because you have more whistles and bells and functionality and so forth. And as Jenny mentioned, we have these all these ancillary data that we have incorporated to support the science data from the NASA observations, the satellite imagery and the active fire detections, aerosol mapping and whatnot. But sometimes you just need to know where those fires are. And, as Jenny mentioned, we have the fire detections, and you can dive down in here and take a closer look. You can see we got a lot of prescribed fire activity. And as Jenny mentioned, this information is harvested from the National Interagency Fire Center, from the fire reporting systems. This data is dynamically updated all the time, continuously throughout the day. So you'll see incidents popping up when they occur. And zooming back out here, you can see we by default, we're displaying all the incidents that are greater than 1,000 acres in size. If we wanted to see the ones that are greater than 10,000 acres, there's only one. If we wanted to see all the ones greater than 100 acres, there's even more than we had before. So let's, we go dive into there. And it's this North Zone complex. If I turn it back on 1,000 acres, you can see all the other incidents that were going along there. And you can see the great uh, being provided through a service through NIFC. And you can look at the detections. We can take a look back over the past couple of days, look at the fire detection activity. I can click on any of these incident points, get information about the basic information about the incident, at least like how big it is, how far along it is in containment. In this case, it's 100% contained, the type of incident management team that's assigned to it, and also the date of when it was discovered or ignited. And you can click on this link here and go to the National Interagency Fire Center's Incident Management Situation Report, which will have some additional information about this fire and other fires if you're interested. But zooming back out a little bit to the national level again, let's see what else is going on in the world here today. I'll turn off those fire locations. Jenny mentioned from NOAA, the National Weather Service, we tap and harvest the fire weather watches, which are the brown polygons here, and the red polygons or pink polygons here are the red flag warnings. These are issued by Fire Weather Zone by the National Weather Service. And red flag warnings are where you have conditions that are prime for fire, at least high severity fire, if you will. So very dry conditions, hot temperatures, low humidities, and the fire weather watches are where those conditions are going to be, those red flag warning conditions would be coming about in the next 24 to 48 hours. So, you can click on these and get that information when that red flag warning was issued, when it's going to expire. Click on this and go to the Weather Service link for that particular red flag warning issued for that zone and get additional details on what the forecast is going to be. Dismiss this here. And then turn those off. Fire danger forecast, we do have that as well. Not a lot going on right now. I just turned on the Canadian one. It'll take a second to pop open here. There it goes. Just in the southern tier of provinces there, they're issuing their current fire danger forecast for today. And if I pop over there, we harvest this information from NRCan. This is their, you can see the same data I was just displaying there. We harvest that from a service they provide. And we do the same thing for the United States. At the moment, we're currently replumbing the location of where that fire danger data for the continental United States is housed. So right now it's not available, but we'll be getting it plugged back in here soon. But it's the same kind of adjective fire danger rating that's updated every day, and this is based off of latest meteorological observations and forecasted weather for the upcoming days, what the anticipated fire danger is for both the Canada product that I just showed you a minute ago, as well as the US product. Turn that all off. And then, as Jenny said, just another reminder on here, there's just a lot of data we have here, whether it's the ancillary data or the satellite imagery and derived products. Click the little eye here, you can get information about any of these products, and then click on the link here and it'll take you to the authoritative source for those given layers to get more information there. So let's take a little tour here. Steve showed at the beginning of the presentation, the extended or long-term forecast for fire danger outlook, if you will. And yeah, Minnesota and the upper Midwest is looking pretty red there, expecting above average conditions. We had a pretty dry winter and whatnot. And the state typically has a lot of those grass fires in the west and southern part of the state, and then up in the northern part you get a lot more of those timber fires later in the summer. And I was just kind of poking through the news and saw that you had some fire activity back in early March out towards the west part of the state. And bear with me, we'll take a little tour here to Waseca. And if I'm not pronouncing that right, let me know. But just looking there that using the location tool, I just did a little search for that, and I can jump right to it. As Jenny highlighted this before, I can save this and save it as part of my location, so I can jump back to it easily in the future if I want to, just by hitting the save location button, and it'll show up in my archive to save locations. But anyway, I'll just dismiss that for right now and zoom in here, because I know there was some activity here by looking at the record in this area here between Rice Lake and Watkins Lake. And so if I go ahead and turn everything on, but I'm still on the 4th of April today. Like I said, this is last month. So if I hop on the calendar, and let's jump in a way back machine here to the 3rd of March. And here's a bunch of detections here in that area that I was speaking about before. And if I click on these, you have the typical GIS type capabilities there. I get the information of the attributes about those detections. These were detected by SNPP VIIRS. And it gives you all the attributes about that detection, including the time and date that it was detected. And you'll notice when you're in firms, it defaults to the local time where your computer is located. I'm in Mountain Time, so that's why you're seeing that. So, we like to work in UTC a lot, so it's, standardized time protocol. And right now during daylight savings, Mountain Standard Time is 6 hours behind UTC, and in the central time zone, you'll be 5 hours difference there. So I can see on the 3rd of March, this was detected at 1938 UTC. So at that time, it wasn't daylight savings yet, so it had been 6 hours difference there. So it had been about 1:38 in the afternoon central time. But anyway, I have this cluster of detections there from NOAA 20 and SNPP and whatnot. And as Jenny, mentioned, this this VIIRS data is 375 meter resolution for the active fire detection data. For MODIS is 1 kilometer. And for GOES, it's 2 kilometer. And for Landsat, it's 30 meters. So you have all these different satellite sources, all at different spatial resolutions. And just, just kind of highlight that a little bit here. I'll do a quick, using the measuring tool. You can see that I'll do some rough digitizing here. That's roughly a third of a kilometer. It'd be 375 meters. If I got in there closer, it'd be closer to 375 meters. Just so you got that idea, that's a 375 meter detection. Now, that doesn't mean the entire pixel is on fire, though. The remote sensing science behind fire detection, you can have a very intense small fire burning within the pixel footprint, and that'll trip the algorithm, if you will, that there's a fire. And again, that doesn't mean the whole pixel is on fire. In that example, you can have other situations where you can have a broader burning fire, maybe not burning as intensely, and that will still, that will also trip the trigger as well. So that's the first rule: is don't always assume that the entire pixel where a detection has occurred is on fire at the time of satellite overpass. So if I take a look at these, pixels here, and I can put them in a time-based classification, and I'm reaching back over a month here, looking at hours. This is going from the end of the day for that day when I'm looking at the hour classification in the time sense detection, or if I'm looking at the days, this is all within 1 day of the third. That's why it's that dark red color, and so forth. And so anyway, let's go back and click on those again. So it was detected in 1938. UTC, and that was at the time of satellite overpass, at least for SMPP. And NOAA 20, let's see if I got some of those. I saw those being there before. As 1849 UTC. So I got some detections, both within about an hour or so of each other, between NOAA 20 VIIRS and SMPP VIIRS. And with 1849 being the earliest detection. But again, that's just at the time of satellite overpass, because these are polar orbiting satellites. So if I wanted to find out when did this fire really start, if we didn't have any ground observations to tell us that, well, we could use our geostationary data to help us out there. So again, if I turn them all on here, now I got all kinds of detections going on here, and you can see the bigger pixels, as Jenny referred to. We got 2 kilometer detections here, but the difference, is on the observation frequency. As Jenny said, every 10 minutes we're getting a look here. So potentially we could probably see if there was some fire activity that was detected earlier than 1839 UTC, and that's what we're going to find out. And so we have this sub-daily button here in the advanced mode, where I've toggled that on. You saw my time bar changed here from simple dates to, it shows me the hours within the given day. So I am on the 3rd at, it just defaulted here to the 2040 UTC, and I'm looking back 4 hours. So I know that detection I saw with VIIRS was about 1839. I can adjust my time either by just clicking it here and putting in time, or I can just dynamically slide my bar along to, let's say I want to go to about 1830 UTC. And then I'm reaching back, an hour and a half here. Well, maybe I want to tighten that up a little bit. I can do that to the last 40 minutes. I could take it down to 10 minutes or so if I wanted to here. But as you can see, all my detections are being displayed at the time. Before I adjusted those time constraints, now are whittled down, and we're only displaying the ones that meet my criteria, and disregard the display of the pixels here. That's just the cartographic display issue within the viewer. These are intended to represent 2 by 2 kilometer pixels. But if I click on those, you can see that, GO 16, which is goes over the east coast at 75 degrees latitude, or longitude, I should say, detected this at 1821 UTC. So 18 minutes before that detection we had at 1839 with that NOAA 20 overpass, or SMPP overpass. And this was detected at 1821 as well. So you can see how you can use the geostationary data acquired at finer temporal resolution Even though it's coarser spatial resolution, it can give you an idea of maybe detecting and get some earlier idea of when the fire was occurring and detected. And if I turn that, what that window is, but I'm going to move that here for a second. I think that might be my zoom window there. So if I go back to daily, I got all these pixels all over here. Now you probably want, this is a good example what Jenny highlighted from the distortion you have to work with, if you will, with geostationary data. It goes 16, the easternmost goes is sitting again at 75 degrees longitude. And so by further north you get and further west you get from that point, it's 75 degrees west, 0 degrees north, that instantaneous field of view, those pixels get stretched and distorted so that the geospatial or the geolocational accuracy suffers a bit. That's why you kind of see them spreading out, if you will, from where the actual fire is. So let's turn those off for a moment. And let's take a look at the higher resolution imagery. If I take a look at the um, the MODIS imagery that day or the SMP VIIRS imagery that day, these data, since they're relatively coarse. So let's look at the finer resolution stuff. So the Landsat and Sentinel data. If I turn on Sentinel and I draw up that image, I'm looking at a true color composite of Sentinel-2 imagery. Sentinel-2 is collected natively at 20-meter resolution for most of its bands. And as part of the HLS data set, so it's harmonized with the Landsat observations. They're harmonized to 30-meter resolution. So this is a true color image on March 1st, because when I'm looking at imagery, I get this little gray tab here, or the day I'm looking at. And that's what that looks like there on that day. Things are, we're coming out of winter, things are pretty senescent and whatnot. You have bare fields and so forth. And as Jenny mentioned, we don't get Landsat and Sentinel-2 observations every single day for a given location. With Landsat, between the two Landsat platforms, we can get an observation every 8 days. With Sentinel-2, there's two sensors or two different satellites. They have a wider swath. We can get a look between those two about every 4 to 5 days. Well, I can also look at a false color composite of that Sentinel-2 image, and it takes a second to draw in here. So again, this is same satellite observation. We're looking at the shortwave infrared band, the near infrared band, and the red band here. And we're taking advantage of how the shortwave infrared energy interacts with the moisture and the vegetation and the soils. These barren, dry fields are showing up very red because the shortwave infrared energy is reflected highly by those very dry soil conditions, if you will. However, where you have moisture in the soils or in the vegetation, particularly the vegetation, that just absorbs that shortwave infrared energy. And so it's reflecting higher in the green gun for the display where we have the near infrared band loaded. And you can see you get this strong vegetated response in those areas of reasonably healthy vegetation. So this is pre-fire on the 1st. And I know that there was a Sentinel-2 image acquired on the 6th here, and we'll let it display here. Here it is in true color composite mode. You can see in the is a regular RGB composite. Oh, there's our burn scars. These are roughly, I've measured them before, I think about 800 acres, give or take, a piece. But if you look at them in the false color composite, take advantage of that energy matter interaction there, these burn scars jump out at you a lot easier. You can see that that response there. Anyway, let's jump on to the next example I wanted to show you here. And I wanted to give you an example of some recent fire activity, at least for larger fires. And we'll take a look at the Greenwood fire in 2021 up in the north part of the state here. And so if we take a look at that, that fire in 2021, but roughly around the mid part of August, it got rolling pretty good. So I'm looking again at August 22nd, the detections on that day reaching back for 1 week here. And I got a cluster detections here. I got my MODIS and VIRS detections. And as Jenny mentioned before, I can go to my time sense detection classification here, either by hours or days. And looking at days here, you can see those redder colors. Those are the most recent detections that have occurred on the 22nd, going to those lighter colors, reaching back further over the last 5 days. And I can take a look at the imagery, see what's going on here. Here's a true color image. And you can see some smoke coming off of there. Turn these off real quick. And if I wanted to look at that in the false color composite, like I mentioned before, you can see all the healthy vegetation. You still see the clouds. You can see a little bit of smoke still there, and you can see a little bit of orange there. That's where you got an active fire burning in the imagery there at the time of acquisition. So let's jump ahead one day and see what's going on. It's like, wow, we've got a lot of stuff going on here. Heavy smoke column getting pushed off to the east, and this here, all this orange glow you see when you look at a false color composite image, like I've shown before, that is active fire front. And so if I go back up and turn my detections back on here, we've got a lot more activity that we're dealing with here. Again, I'm just switching my classification between hours and days on that reach back there. And so you can see what's going on there. So let's jump ahead to take a look at area burned. Jenny highlighted the burned area product because you can't always assume that the cumulative fire detections will equate to area burned. So you need to, that's just a function of it with the polar orbiters, not having that persistent observation of fires. And sometimes you have fires moving really quick through finer fuels like grass and whatnot versus heavier fuels like trees. Sometimes you do have a pretty good one-to-one correlation. Other times you don't. So if you're actually looking at burned area, we have the burned area product. And if we looked at the cumulative fire detections that we have for the Greenwood fire, this is from the 17th of September, looking back over the past month. This is all those detections. It covers pretty much the whole time of burning of that fire. And if I look at the satellite imagery, again, looking at my false color composite here, where I can really see those burn scars easily. Yeah, I can see it going on there. You can see the burn scar appears that deep red here, where it really burned more intensely, not quite as red here, where it's burning less intensely. And I can look at the Terra Modus as well, which is the same day. It was acquired just from a different view angle and a few hours earlier. Again, you can see that burned area pretty well. Well, as Jenny mentioned, we have a burned area product, and that product is not provided in near real time. It's provided, about 2 to 3 months after real time, if you want to call it that, and it's compiled as a monthly data set, and it's compiled at a spatial resolution of 500 meters. And the way this product is compiled, it conducts a time series analysis on the imagery itself, as well as it ties in the active fire detection data, so that we can identify change on the landscape that's occurred, and then we use that fire detection data helps us flag or identify the areas of change that are due to fire, and so we're not getting confusion from other types of change on the landscape. And then again, you have these monthly data sets are available. So I just drew them all up for the whole year, so you can see that Greenwood fire, burned in August, which is what we expect, after looking at those fire detects, and we got some of the activity that was detected and classified as occurring in September. And then over here, we've got something that's going on later in the year, in October, a little bit of fire activity there later on. So again, since we're using the surface reflectance data, the imagery, along with the fire detection data, we can map out that entire burned area, which is underrepresented by just looking at it with the fire detection data alone. And if you're interested in taking a look at the activity over the whole year, I'm just a different view here. Here's the entire state of Minnesota, the MODIS burned area product, displaying all the months for 2021. There's that Greenwood fire. Looks like we had some activity across the border in Ontario. I could jump back here to 2006. Takes a second here to refresh. So you got some activity showing up here by the Red Lake. Here's that fire there. I think this was Cavity Lake in 2006. And then you got the Ham Lake fire, which was right next to it in 2007. And that it's up in that area. I think we had that big blowdown event back around 1999 or 2000. There was a whole massive amount of down timber there that a lot of those fires had burned through over the years. But anyway, just to give you an idea that you have all that burned area record data available to use. Let's see, the next thing I want to go through is I wanted to highlight a little bit about the latency of the data. You know, Jenny mentioned, we got all this data going on, and she had that big table she showed in the first part of her presentation where we had, here's all these satellite sources, and here's how quickly we can get those data after satellite observation. With the data that goes through the regular channels and how it gets bounced from the satellite down to a ground station and then goes through the data processing pathway at NASA and whatnot, we can get active fire detections roughly 90 minutes after observation, give or take. It varies a little bit from day to day. The maximum window they could ever take in the worst case circumstances is about 3 hours, but it's typically around in 90 to 100 minutes. It comes out, like I said, sometimes a little better. We can also use what we call ground stations or antennas that are positioned, and when the satellite, any of those satellites that have the VIIRS or MODIS sensor on board, when they come into line of sight above the horizon, and you have one of these antennas, you can track it from horizon to horizon, and those satellites broadcast the data they're collecting at the moment, at that time of overpass in real time. So any ground station that's on the ground listening, and this is all freely available if you have a ground station set up, you can collect that data, process it, and make it available. And you're just capturing the data, though, for that area of geography that your antennas operates within. And so, for example, the closest ground station to Minnesota is at the University of Wisconsin. They have a couple of them there. And this blue halo you see around it is what we call their station mask. So when any of the Terra Aqua, NOAA 20, NOAA 21, SNPP are with, intersect that halo, you can see collect the data for everything they're seeing at that time from edge to edge of that geographic footprint, if you will. And so that local data, we can get our hands on it much quicker and process it. And the typical workflow is it takes about 30 minutes, maybe 45, to make that data available from what we call a direct readout ground station. Well, the folks at the University of Wisconsin have been working on some updates to that workflow process, if you will. With funding and support from NASA, they developed what we call an ultra real-time data processing workflow for this direct readout ground station data. And so what it does, it kind of breaks up that data collection into small chunks as the satellite's going overhead, because we're tracking that satellite maybe for like 10 to 15 minutes when it goes from horizon to horizon. So it breaks them up in these really small chunks and processes them as it gets them in those little chunks. And then the data gets bounced and gets processed to identify fire detections, and it gets staged, and we pull it into firms. The latency on that is about 1 to 2 minutes. So for any of these ground stations that you see a solid halo around, so the blue one for the University of Wisconsin, the black one's in Hampton, Virginia, this orange one's in Puerto Rico, and there's also one in Miami now that's not shown on here. Those ground stations, we can have MODIS and VIIRS active fire detections displayed within and accessible and firms within 2 minutes of satellite observation. So it greatly reduces the latency, which is really important for fire management if you want to know what's going on the ground, and also as a detection tool. These dashed polygons are for satellite ground stations that are available, and we're working between NASA and University of Wisconsin to get them on board as part of our ultra real-time network. So we'll have that 2-minute latency fairbanks over the entire, just about all of North America. And we're hoping around that corner to get this West Coast station and Hawaii and Fairbanks station online this year. So we'll have that coverage over the whole United States. Here's a quick little static example. This from last year out in our neck of the woods here to show you how that works. Here, some VIIRS data. You can see here the timestamp is 8:09 UTC, which at the is basically 2 o'clock. It'll be 2:09 Mountain Time. And you can see down here, the timestamp on my computer is 2:11. So like within 2 minutes, it was displayed and available. And probably missed it here. This is actually live looking at today. Got all the VIIRS and MODIS data being drawn up here and using the hours classification. So these deep red areas here, you can see this is live in eastern Montana. You have ultra real time. That's how these detections are identified in the data sets you can access. And it was collected at 2043 UTC, which would be 2:43 my time. And if you can see my time now here on the bottom of my computer, it's 2:50 Mountain Time. So 7 minutes ago, that was seen by the satellite and processed and made available. So again, that's available for all the MODIS and VIIRS data. And we have good solid coverage over the continental United States. We're just looking to establish redundant coverage over the Western US and have complete coverage over the Canada and Alaska. And what happens with this ultra real time data, as the near real time data and the science products come in or made available later on by NASA, they replace that ultra real time data. So you don't have like duplicated data sets or multiple pixels stacked on top of each other. It's all automatically updated and replaced with the standard science data. So yeah, so I wanted to cover there. And the next thing I wanted to highlight was the higher resolution data, which is the highest resolution asset we have in firms is Landsat active fire detection data, as well as Landsat imagery and Sentinel imagery. And this is an example out on what's called the Double Creek Fire in Oregon a couple of years ago. September of 2022 is the day we're looking at here. All these detections here are 1 kilometer MODIS fire detections collected by Terra MODIS. And this here is the Snake River. It's the border between Idaho and Oregon, just so you got a rough idea where you're at. And I take a look at the the MODIS imagery here on the same overpass where these detections were identified. This is a true color composite. You can see all the smoke coming off the fire, and just you take a look at that and see the time of overpass here in UTC. That's is at 1834 UTC, so about 1230 Mountain Time here. So I have all those detections. If I wanted to look at the false color composite, I can do that. You take a look at things here. You can, again, we're looking at MODIS imagery here. The imagery from MODIS is collected at 250 meters or 500 meters, depending on the band. The fire detections, the thermal data is collected at 1 kilometer. So it's more coarse, but the imagery is a little finer, but it's still kind of fuzzy. We would all like to have higher resolution data. So if we take a look at the HLS imagery and draw up that Landsat image, this is the true color composite of that Landsat image that was acquired within 3 minutes of that Terra MODIS overpass. And you can see all this, interesting stuff going on here. This is because of the surface reflectance correction that's trying to be applied to the imagery and ways working with that smoke in those visible bands. But if I look at that false color composite of the Landsat image, so we're looking at a 30-meter image here. You can see how much finer it is compared to the MODIS image. And you can see the active fire fronts here. You can see there's some fire going on there. There's big bunch of fire going on here. And if you look close, you can see some other smaller spots like that there. And if I draw up the active fire detections from Landsat that occurred at that same time, you can say, oh, I can't really see it very well. I may want to make it yellow, so it sticks that a little bit better. And if I wanted to toggle it on and off, I can see where it relates to those fires I can see in the imagery, or I can, adjust the opacity on the fly too. Some of that stuff like that Jenny was showing you there. So just to give you that idea there, we have those higher resolution assets available. And some of you are probably wondering, what can you get active fire detections from Sentinel-2? That's something we're working on. It's the algorithm exists that was developed by NASA. The implementation is the hard thing because we'll need to work with the European Space Agency to figure out how we can tap their operational data stream for global Sentinel data and make that data available, if you will. That's something we're going to try to work on here in the coming years. So right now, though, our Landsat active fire detection data is available for all the continental United States and the southern tier of Canadian provinces. We use the data that's collected in real time at Aeros Data Center in Sioux Falls, South Dakota. And so all Landsat 8 and 9 data are processed, and the active fire detections are available about 20 minutes after satellite overpass. So it's very, very quick, very low latency. Let's see. The last thing I wanted to go through real quick. I know we're running short on time. Time check here. Just wanted to highlight, as I said before, you can access all these data, the fire detection data from these various satellite sources in a variety of formats. We provide data from Modus, VIIRS from all three of the different satellite platforms that have VIIRS on board, and also Landsat data. You can download them as Esri shapefiles. You can get a shapefile for the last 24 hours, the last 2 days, or the last 7 days. And the data is all ready to go and fully attributed. And you can download it for these predefined subset areas. You can get them as a Google Earth KML, again, also for the last day or 2 days, and from all those different sources. And in this KML, the fire detections are just represented as a simple point location with a little flame. And you can get a more robust KML that actually shows the pixel footprint at the nominal spatial resolution for the satellite. And also they're classified and symbolized based on their time since detection and classification within the last 24 hours. And again, you can get these for the last 24 hours, 48 hours, 3 days, or 7 days. We talked to our friends up in Canada. They said, could we, carve those up, if you will, or subset them by, Canadian province and territory. And, we've done that to meet their operational needs there. And of course, if you need them as a text file, as a comma separated file, you can download them again with those time intervals just as a CSV. In the interest of time, I'll just highlight web services real quick. If you like to consume this data, on the fly or dynamically in the streaming service, we provide web map services. All you need to do is request a key from NASA. Just put your email address in there. There's no strings attached. There's no cost or anything like that. And you'll be granted a key by default. You'll be given 1,000 transactions for every 10-minute interval. If you need more transactions than that, reach out to us and let us know. And those we can talk about boosting those transactions to meet your operational needs. But you'll end up receiving a key, and you can access all these services. We made all the services predefined, if you will, with a default symbolization to show them all as one symbol. I'll let that drop here for a second. And here it is globally. You can see here's all the SNPP VIIRS for the last 7 days for the whole world. And you got all the flags on here where you can use GML there to set the parameters. You want to readjust the subset display and whatnot. We also have services that are predefined with the time since detection classification for the last 7 days, like we do with the KMLs and displaying them on the map. We have a very similar one where we have, again, over 7 days, just a different time classification. This was to meet the operational needs of the fire management community for some particular applications. So that's why we have multiple versions of that. cumulative year to date. Maybe you want to have all the detections from January 1st through the whole year up to the current date. We have web map services that will address that. And the MODIS burned area services, the burned area product I showed you before, you can access that for the entire 20 plus year MODIS data record. And web feature services, if you're interested in getting at that data, let me jump over here just really quick. And again, you need your map key to access this, but we have web feature services so you can actually stream and consume the features for those fire detections from MODIS and BEERS and Landsat into your GIS client, and actually manipulate those data, conduct analysis with them, symbolize them, do whatever you'd like there, and use them as you see fit. And we also have an API. Back up here for a second. If you have some scripting you want to do and you want to, you can, do a curl script or whatever to pull these data into your application. You can do that as well by, using again your map key. I got Art Pro starting up here on the side. Sorry about that. I was going to show a demo on Art Pro, but in the interest of time, I won't do that. But let me get my map key handy here. So if you wanted to pull these data from MODIS or Landsat or BEERS and consume them in your own customized application, you can do that. Again, you need your map key. This is my map key. This is an example of what it is, large alphanumeric string here. I can put in some coordinates. So let's say -125 for the west and 25 for the south and -55 from the east and up to 45 degrees for the north. I'm going to grab all the SMP BEERS data. And this date here, this forms your baseline date. And if I say I want to get 4 days, so if I want to get everything on March 28th plus 4 days forward up to like, what's that, April 1st, I can do that, display the results, and there are the results there. So here it builds the string for you. If you were going to write your own little local script in Python or something like that to go out there and harvest that data from the WFS API, you could do that and write yourself up a little script so it just gets returned, and you get all that data ready to go. So I think I'll stop it right there because we're running out of time. So thanks for your time there, and I'd be happy to do any go backs or answer any questions.